Alright, still working with the new elements here. Hello, and welcome back to another Binary Ninja stream. I hope you guys are doing well. Today we're going to be focusing just on some basic beginner C++ reverse engineering. So let's get started. There we go. So this is going to be based off of a very simple binary that I wrote myself. You know, and it's your traditional sort of inheritance structure where you have some animals that are derived from that animal, and then we also have a pet which derives from one of those derived classes and the pet class. Pets are named animals. So we're just going to go through this and see what we can do, see what we discover, and mark up this B&B. Of course, you guys are welcome to contribute however you want. In fact, I want to drop this binary in the streams channel in Slack, so you guys can follow along if you'd like to. So let me get that together. This is a Mako, so it has with both the x86 and ARM version in it. So we will be taking a look at both because I am curious about how they're different a little bit. And I'll also give you guys the source code to this. If you're not in Slack, you can go to slack.binary.ninja and join today. And that's in the streams channel. So you're welcome to follow along. Let's just dive in. This is main here. We've got pets. We've got basically the same thing, but happening on the heap with some deletes to see if that changes anything. We're going to be calling, let's see, we've got our animal here. On the animal, we're going to be calling kind and speak, but we're also going to be calling that on the base classes. So we're going to be seeing what that looks like. One that sticks out to me is the speak twice function, is I believe a virtual function. So we're calling it what looks like on the base class, but we're actually calling it on like the cat or the base animal or the dog potentially. All right. Um, so what do we know about C++ to begin to start reversing this? Usually you're not going to be passing a reference to yourself to a constructor, but if we look over here at the stack, it kind of looks like all these objects are just living on our stack. So we're going to need to create some types for them, of course, but then the constructor is constructing the animal on our stack. So I think this is going to be just our animal A here. I'll call animal A, we'll call cat C, let's call dog D, and pet will be P. Um, Sweet. So that's most of the variables so far in this function. But we also should go ahead and create some of these variables, these types rather. I'm going to pretend I have no idea what the source code of this program looks like and just reverse this how I would if I were coming across it in the wild. When we're done with this, I do actually have a different CTF problem that we might work on, um, which also has some VTables in it, but it's strict. So if we can do it the first way with some known source, hopefully we can do it on the stripped binary afterwards if we have time. I'm only going till 5 today. Um, it's a weird Wednesday stream if you guys like it. If it seems like we're getting more engagement on a Wednesday than a Friday, we could change to Wednesday, but the next stream is going to be next Friday. Not this Friday, but the one after. Just before Valentine's Day. Should be a lovely stream. All right, so let's create some types from CSource. We're just making a couple empty classes. Class animal. We're gonna do the cat, the dog, and the pet as well. And yes, I should be using the base classes and oh, it doesn't like this? Oh, of course. There we go. I should be using the whole create new structure, base structures, X inherits from Y. We're gonna have to remake these types later once we have some idea of what's in them. But we don't yet know what's in them. So let's go find out. We're gonna start, let's just apply these types. This is going to be an animal. This is going to be and we actually do have a hint towards the size. We could, if we want to, guess that a pet is this big, a dog is that big, a cat is that big, and an animal is also 16 bytes. I'm not sure if that'll hold true. If you guys have votes, throw them in chat, and I'll be happy to make them with default sizes. Otherwise, let's just, oh, that was the wrong button. Create the type is cat, the type of D, min Y is dog. The type of this is pet. There we go. So we have our animal, our cat, our dog, and our pet. The bytes, they should be consuming more bytes, but we'll figure that out later. I suspect a lot of this is also padding, but we're not sure. So if we go into animal, the first constructor here, the first thing I want to correct is going to be the type signature here. So obviously this is taking not an animal itself. We don't care about that over there. We want, I'm going to leave, I'll put it over here. We're going to desync this pane. I'm going to leave this in high level IL. We're going to go back to main underscore main, of pets rather. And we're right here. So this is taking a pet pointer, not a 32-bit number. And this is probably going to be called this. We can call it this from the rename menu if we hit N there. But if we wanted to do it from the type view, we need to put backticks around this for the type parser to be happy. Are you guys not getting audio? It does say that it's sending audio from my side. So hopefully you guys can hear me. Um, Testing, testing, testing. Okay. I can hear myself too on my test stream. Can't give me heart attacks like that. Come on. All right, so we're constructing this. This pointer is going to be the pet pointer. But I'm noticing something weird in here. Binary Ninja is telling me that there are other variables that might be getting used here. If we drop down to a lower level of the IL, we might be able to see this a little bit better, and we might be able to recognize it a little bit more comfortably if we are in an architecture we're a little more familiar with. I'm more familiar with x86. I assume you guys are a little bit more familiar with x86 as well. Let's create our animal pointer. This. Uh, Animal pointer. We need the backticks around this. We've got this, we're passing this to that, but we also have RSI here. We can see on the x86 side, and RDI actually as well. Well, RDI and RSI. But what are RDI and RSI on x86, and what is x0 and x1 in ARM? They're going to be our first two parameters to function calls. So in this instance, Binary Ninja is actually failing to recognize the extra parameters going to this constructor. But that's not so bad. We can actually see the constructor calls a constructor. So we do need to go inside that constructor. Is this also desynced? This is desynced. Let's quickly put it in sync group 1. We'll go to high level IL. Will it navigate backwards? Oh, I was hoping it would navigate me backwards here. We were in animal. We can desync this now. No sync. Um, and I'm just sort of using my pains to keep track of where we were and what's left to pop back up the stack to at the moment. Um, And then, all right, so we're in animal twice now. Let's go into the inner animal constructor. And we're going to need to do the first thing again, which is propagate some of the type signature information. There is a way to forward propagate types. I do believe that because we're accessing a D word from this, um, that forward propagation doesn't work in this case. So we're going to do it manually, which is fine. We'll just click into this function. I'm going to change the type of this now to be the animal pointer this. And we're seeing now some hints towards the size of the animal structure. We can see that the first offset is being set to some data, which is a VTable, I guess. We'll find out later. It looks like to some function pointers that are associated with the animal class at the very least. So I'm going to hit S on that and say function pointers for now. And then this is interesting. X1, we know that that should be the second parameter to this function. So let's hit Y on the type of the function to change the type and give it a second parameter. Binary Ninja thinks it might be a 32-bit integer. So let's try that. In 32T, arg2. Well, that cleans up the decompilation. Let's just call this value for now. We don't know what this value is, so actually let's put a question mark after it because I'm not so sure what it is yet. And then, I'm tempted to rename this variable, but let's go backwards for a second. We know up here that, oh, okay, now Binary Ninja thinks it's taking x1. Where is x1 coming from? It's an argument to this function. So as soon as I update this prototype as well to have that int32 in there, I just hit down arrow to get to the last thing I entered since the type signature for these two functions are the same, and hit accept. It updates our decompilation in main as well. So now we can see that animal takes the pointer to the object we're going to be constructing. And then it also takes some sort of value to initialize the class with. We can pop open our cross references if we would like to see where else this is being used, but I don't think we've propagated our types, excuse me, through this program enough to really see those cross references yet. All right. Um, animal, this. Let's call this value for now. Call it value out there, and we'll name it value in here too. All right. So I think we're done with these three functions, the animal constructor. We're not yet sure what this does. When I Okay, cool. The cat, the dog, and the pet all seem to be propagated, also seem to have a second parameter, is what I was checking there. Let's redo my annotations. We are still seeing this one equals this thing. You might ask, does that mean there's a third parameter? I don't think it does. I think it is literally just copying something onto the stack and back. But I could be wrong there. It could be, oh, thank you. I could be wrong here. There could be a third parameter. In fact, if we add a third parameter, what does it look like? Let's go back to high level IL. I want this up here back in main. And if I change the type of this again, let's just say it takes, well, this would be a pointer. So if we say there's a void pointer in the type signature, it doesn't make anything look better. And often, and yeah, see, this is just entry. So if there's not an actual real parameter being populated, real third parameter being populated to this function. So if you ever do something and it looks worse, just undo it. All good reversing tools have undo. Um, and that's why guess and check is a perfectly valid strategy. You can almost certainly apply live values from the debugger into binary ninja if you'd like to. In particular, if we did can you remote debug Windows targets from macOS? I'm not sure you can, but on Windows you can certainly attach to your um, x64 debug. I'm not messing that up. Someone can correct me if I'm wrong. All right, so we've got this, which almost certainly is actually almost certainly has two actual parameters. Um, and doesn't look like it has three. Certainly doesn't only have one. So we can move on to the cat. Let's go here. Cat. There's gonna be multiple of these. So it's gonna ask me which one I want. I'm not sure which one I want. Do I want the A4C one? Or do I want the uh, DAC one? Let's put these together now. When I double click this one over here, it's bringing me to the top one. And we can see that this one's calling another cat. It's not calling itself, it's calling this one. And that's interesting. We can see that the cat actually constructs the animal internally, which is what we'd expect. We expect to have in an inherited class, the base class should be the first thing in it. But let's propagate our type information forward. We know that this needs to take a cat pointer. We're gonna call it this again. I'll copy that. I'm gonna apply that here as well. Um, okay, now we're seeing some offsets into the cat. Let's create, we know that well, we suspect that this first one is going to be function pointers again, and it does look like that. So I am tempted just to create that, in the cat there, and then also create whatever this value is. Oh, and it does look this time that we have a third parameter. We're seeing it being used up here. We're seeing it being used up here. If I add a third parameter, Binary Ninja thinks it could be a 32-bit number. So let's believe it. See what that does. Arg3. Okay, arc3 appears unused, but we need to keep going. Hit Y here, hit down, hit enter. Oh, interesting. The type you entered is 0 width. Do you want to use a pointer instead? You entered void cat pointer this. Okay, yeah. A cat pointer. Well, the cat class is actually more than 0 width. Use my type. Oh, yeah, no, that's not right. That's not right at all. What did I do? Oh, I hit Y on one of the parameters and hit down arrow. I meant to hit Y on the function object and hit down enter. That looks more correct. So we still see this weird this equals this thing, which is again just temporarily storing the pointer on the stack for some reason. We can come back to that as maybe something weird to look into. In fact, the way I would recommend is saying probably add a tag, and maybe needs analysis. Might be inconsequential. There we go. All right, so we've got our cat, and we're constructing the cat. We're giving it two values. It looks like that is true from main too, so everything looks right. We're probably moving in the right direction. And we'll just call this val1. We're gonna call this val2. All right. So we got this, we got val1, we got val2. Let's update those names over here. Not val21. Oops. There we go. And you can see there, when I misnamed the parameter, since these parameter names don't match, Binary Ninja is showing the name of the parameter inside of the function, and then what it is in our function. We're seeing that over here as well. It's just helpful. It's not real C syntax, but we're not looking at C syntax. We're looking at high-level IL. And the reason we're looking at high-level IL instead of pseudo-C is because it has little extra bits of information like that for us, that we desire when when we're thinking about programs, in my opinion at least. So let's redo that, and then I think I need to, I didn't up, the analysis information didn't automatically update for this function when I redid that change. So I had to hit that refresh button in the top left. But now it's starting to look a little bit more correct. The one caveat to this is that we know that the animal um, object takes a pointer to itself that it's constructing, and those function pointers are being set to the animal's function pointers. So it looks like we're still doing that. We're still setting those function pointers, but we're also copying this value, and then we're overwriting those function pointers with the cat's function pointers. So this first field here of cat is not a 32-bit integer, but it is an actual animal object. So let's say animal A, and that looks really clean now, actually. It filled up that whole struct. On the right here, we have, let's name this value, just to match. We're not sure what value and val2 are, but I'd at least like the name of the variables that appear to be the same thing to be the same. And now we have this weird val2. And hopefully later we can come back and find effectively um, what this val2 is being used for and what that value is being used for. And we'll once again go through and rename everything that we need to update. Although it would be an interesting plugin idea to be able to be like, this variable in this function and this variable in this function should have the same names. So just being able to link them in a sidebar would be really cool. So when you name one of them, it updates all of them. I think I might actually make that. Call them like rename groups or something. I think that'd be a pretty easy plugin. We can write it on stream next week. We could write it on stream right now if we really wanted to. All right, so we see here from this, we're overriding the animal's function pointers to be our own function pointers, which is sweet. Okay, so now let's do the dog. Do the first one that calls the other dog. We'll do the second one down there. And now it's just a bit more of the same. We know that, yeah, let's just do it from here. Y, dog pointer, this. It probably also has a second value. We need to change the type of the entire function to adjust for that. And 32t there. This is probably going to be value. Now let's update this. Hit Y on that. The first parameter is this. The second parameter is the value, and the third parameter is still, well, is another value. We don't know what it's being used for yet. And now in the dog class, we can set the first, I'm just gonna hit S on that. So it gives me something over here to click a little bit better. I don't need to, I could click that first question mark and hit Y instead and make that the animal. But sometimes I like to do it one way, sometimes I like to do it the other way. And let's name this underscore animal. I think that's just, oops. I double clicked that by mistake. I just want to rename this animal. Streams are all saved. Yep, you can watch the VODs on our YouTube channel. Casually chop licenses in the chat. I wish. Eventually we'll probably do giveaways and stuff. Yeah, I'll let someone else speak more towards that. It'd be fun to do something at Reverse like that. I do plan to stream during Reverse a little bit, by the way. I'm hoping to get some interviews in with people, ask them hard questions. Um, see what they think, see what they have to say. All right, so we've got dog. We've got those two values in the dog class. I accidentally closed this window over here. So let's go back to no sync group, dog, hit tab to get back up to the disassembly. And now we have this dog animal function pointers are being overwritten with the what I assume are the dog's function pointers. And we have that weird val2 again. What do I call it in cat? Oh, I called it val2 in cat. So let's call it val2 in dog as well. I'm not expecting the cat's second value and the dog's second value to be the same thing. So I wouldn't want to group those, but I do think, yeah, I think they're separate as well. So let's now check out. So, we have those weird values there. We've got pet. So if we're just to finish up these couple of classes, and then we might need to go back and redefine them with the correct base classes stuff. But I just want to finish annotating these functions. So pet, oh, I hit Y instead of G to go to, I want to go to pet. There we go. There are two again, so let's do the first one on the top. And then I think the easier way to do this is actually double click into that, make a split pane, and then hit back on the first one. The quickest way. All right, so okay, pet looks a little bizarre. There is a string in here, a very nasty unrolled C++ with this weird ABI thing in it, which is why our template simplifier is not correcting it. I don't think I've seen that square bracket syntax before, potentially. Um, but anyways, we've got our pet. We know that the first thing that it's going to be taking is going to be the pet pointer, pet this. Unfortunately, we can't pet this in Binja. I think we need a pet function in Binja. This second value is, this is still just some weird value we're giving it. Although Binja thinks it's the const pointer. If we actually look in here at R2, do we agree with that? Why are these lines highlighted? because I'm in a sync group. Because I'm not entirely sure why those lines are highlighted. Um, anyways, maybe I have something selected over here. Oh, interesting. No, I'm not entirely sure what's causing that. But anyways, we have our second argument here. The highlighting is messing up, but we can see that that is that weird value. Do we have any other values that are being used? Yeah, we have a third parameter for this function. So let's give it. Um, this is going to be an int32t. Let's use as our guess. We've been using that for everything else. That's entry x2, so let's update this. Int32t. Does that look right? Kind of looks right. What's this? What is this? If we drop down to the disassembly for a second. Oh, there's some data. There's a string there. We're not seeing it yet, though. Is this supposed to be the address of that string? Oh, well, I've defined it as an integer. So let's actually just give it a go. Pat, we think this one's an integer, because that's the value down here. So yeah, I think it's pretty safe to say that this is our int32t value. We're gonna rename that as well. And now this is our character pointer. Presumably the name. We need to update this as well. This is going to be a pet pointer called this of some spelling. And then we've got our name as well. So let's create the character pointer for our name. And now we can see here we have, oh, I guess this is the internal string. I don't know what we call that. Maybe stir, thunder stir. Um, Interesting what that's doing there. Named this. So inside of the pet, it looks like, have we not done named yet? We have not reversed name yet. So we need a new name class. Named. We won't give it a default size. So it'll be empty for us. Hmm. It also created that as a struct. There's very little difference between a class and a struct. So let's just go ahead and, how do you edit that? Change type. We can just make that a class. Um, Command enter will close that dialog. Okay, so now that we have named, we can go into named in the bottom right here, and this is almost certainly taking two arguments here. It looks like it's actually taking a structure, which makes sense because it should be taking the named structure. So let's go ahead and hit Y on this. Named is going to take, oh, actually, before we get rid of this, one thing I've noticed is we don't actually have std string defined in our program right now. This I think is a legit bug. Current data variable. And if we get the type out of it, oh, there is no current data variable. Because there is a current IL variable, which is the current variable. Just current variable. We can grab the type off of that. I kind of wish it wasn't a const string. Can we get children? Eh, not quite. But let's go ahead and actually define the string class in Ninja. Um, bv dot define type. How do we do this? All right. So we can parse type from string if we want. Can we actually do that for our string? No. Oh, we have no idea what std is. We have no idea what string is. So we can't just parse it. I think we just need to do basically this. But we can give it our own name. So the type is going to be current variable dot type, current variable dot type. I'm just seeing that question in chat there. Name is going to be std string, and then I'm gonna just, well, perhaps we can be polite. I don't think this is source. I'm just gonna do like my types or something. Does that work? Sweet, that works. And now do we have, okay, cool. Now we have std string defined, so we can use it if we need to. That's all I was doing there. The question is, why did you need to specify arg2 and arg3 again manually when it is used in the function? Because Binary Ninja just didn't recognize those parameters out of the box. We can recognize that they're being used, and when we massage the function prototypes, Binary Ninja can recognize that they are being populated in the way that we think they're being populated. Why Binary Ninja's parameter detection is going off the rails for these functions, I'm not actually super sure why. Um, but it is just nice to be able to see that we can go down to the lower levels of the ILs and recognize, oh, okay, we are actually populating some parameters before we make this call and fixing it up ourselves. Because Binary Ninja aims to do all of it for us, but we're never going to cover 100%. So it's good to know how to catch your own fish as well. So, oh, I realize I'm emoting at the camera, but the camera's off. Anyways, um, so we've got this. I don't think I'll have the stack view open for a while. So hello again. Um, all right. So we're in named. We were working on named. I just didn't want to lose that string class, is what it was. But if we go back to our named class over here, we know that this should be taking a it's the constructor for named, so it should be taking a name. Um, and I think there's a string inside of it. So let's just go ahead and give that a named pointer called this. Sweet. And now we can see at offset 8 in this, we're constructing a string. So let's go ahead and make the function pointers. And then I'm going to increase the size of this structure by 8 bytes. So it can have, yeah, you can see it's just a pointer. Wait, this might not be big enough. I'm not entirely sure. But let's create that field. It's not quite the right type. So let's make it the right type. String, std string, and backticks. Hey, there we go. We'll call this name, and we'll call this function pointer like we called the other ones. All right. So that's actually looking really nice, guys. We've got our name being named class being constructed. We're constructing the string inside of the named class. and we're using, and the named class begins at the offset of 10 in pet. So if we actually have to make pet big enough. So first of all, I'm also worried that string needs extra bytes here. I'm not sure what's completely going on yet. Um, okay, cool. So I see I could go through, I could manually resize the structure and create all the fields, but I am seeing in the bottom right here that Binja has actually detected that offset of 10. This is probably going to be the name function pointers, I would expect. Yeah, almost certainly. Except it's not the named function pointers because it is named itself. There we go. So we have the class named inside of here, and we are setting the function pointers inside of um, the named class. The function pointers inside the named class. We're also setting our own function pointers because pet inherits from animal. Animal's going to set the function pointers, and then we're going to have to overwrite them with our own. But thankfully, we know that we have an animal. So we can just put that in. And then we have a little bit of space between the animal um, and named. So the big question becomes, are these bytes used or are these bytes not used? And I think they actually might just not be used in our case here. But we still have no idea what the value is. Um, I'm guessing that it's a name because the class is called named and it's a string. Could be wrong there. There's a lot of assumptions that we've made so far that we should be keeping track of um, if we're being really, really thorough about this reversing process. Alrighty. So then, um, let's start to see, and we can see that the name of our pet is Buddy. Um, let's go through, and I'm really curious what these values are, how they're being used, what they're being used for. Did we not? Oh, we did. We didn't give this a good name though. Let's name that value. Um, there we go. All right. So then we actually get to the first function call here. I'm sorry for my voice cracking. I think I'm getting strep maybe. That said, um, we actually get to our first function call here. We can close out of this. We can close out of this. And let's just click into here. We can see that it is expecting there to be some sort of first parameter. What is the first parameter going to be to our member functions? It's usually going to be the pointer to this, to your object. So let's go ahead and define that. We're going to have an animal pointer called this. There we go. And now inside of that, doesn't really change anything. It just looks like this function is printing um, the kind of animal it is. And in this case, it's just an animal. Where else do we see kind? In cat, it's going to print potentially dead cat or cat based on whatever that is. So we're starting to get some hints towards how these values are being used. But I just had in my mind something else I wanted to do real quick. Ah, yes. We have effectively namespaces over here. I'd love to be able to make some components for our different classes. Oh, and you can do it from selection. I forgot that. So we can actually just search for anything that begins with animal colon colon, and let's put all of this in an animal folder, and then we'll go through and do the same for cat, dog, and everything else. Cat. And Binge is being smart enough to recognize what it should be doing here. It's giving a really good default name for all of these. That was cat, dog. Did we do pet? No. This is, oh, pet. I might have added these two by mistake, removed from folder. And then name. We'll do all these. New folder. Name. Okay, cool. And now when I don't have any filter in the symbols view, let's actually, for right now, I want to show folders first. So I can easily navigate among the functions in animal, cat, dog, and pet. Oh, and later we'll do the vehicles. We have a vehicle, we have a land vehicle and a water vehicle, and then we have both. Yep, the live stream is recorded. You'll be able to access the VOD on our channel. You guys should be able to scroll backwards in the video right now, actually, too. So you can go back right now. But it'll be up. We don't take them down. And for anyone who's new, who hasn't been here, we're just doing some beginner C++ reversing. We've got this animal, cat, dog, pet named structure going on. We're creating our types over here. We've so far been able to annotate all the constructors, and we've recovered some missing parameters that Binary Ninja just wasn't detecting. And now we're starting to get to the actual member functions of these classes to figure out what some of these fields are. Because we know we have values in here, we don't know how they're being used. And we also need to verify that those 4 bytes are not being used for anything. So the first thing I want to do is really just apply the this function signature to everything that needs it. So this needs an animal. All the member functions of the class are going to take the pointer to the class as the first argument. So again, we'll just do that. I'm just going to copy that, so I don't need to type it every time. A Y, paste it in there. We can do Y, paste it in here, except this is going to be a cat now. This is also a cat. Animals speak twice. We are giving it a cat, but it should take a animal pointer, which is valid. Valid C stuff. Cat's gonna scratch. Cat's going to jump. And you see, Bincha missed all these parameters here, even though under the hood, X0 is getting populated with a reference to cat before each call there. All right. And now this almost is complete here. We've got the dog going to kind. We've got the dog going to speak. And we probably have a couple others. We've got speak twice. Dog will wag. Okay. Why? There we go. There we go. Dog this. And now lastly, we've got a couple more. So animal. Pet kind is going to take a pet pointer. Called this. And there are more arguments to these functions. We just have not discovered them yet. And if we drop down to the disassembly, we can probably recognize a handful of them from the calling convention. Speak. Yeah, we don't care about that. We just want that. And then, did these actually take a? Presumably, right? They don't show it. Um, no, okay, it is populating each argument still. PDCA. So let's do that as well. Pet roll over. That's going to take a pet pointer. And now this is going to take a pet pointer. This is going to take a dog pointer. Come on. And this will take a cat pointer, and this will take an animal pointer. All right. So we've cleaned up everything we can see. What about the things we can't see? All right. Let's see. So there might be things we can't see. Let's go ahead, close our sidebars. We're gonna open up a split view here. I'm gonna look at this in disassembly real quick. Let's leave these in a sync group because this time I do want to match line to line. We can see over here, was that not correct? Sync group one, sync group one. Okay, there we go. All these function calls seem to have just one parameter. This one seems to have one parameter. This one seems to have two. Animal speak twice has that second parameter there. So let's go ahead and add that. Let's just say it's a M30QT. Ah, and there you go. It recognized that second parameter in a bunch of them. Apparently, it's always called with the parameter of two, which is weird. Um, okay, interesting. Oh, I missed cat get lives. Let's hit Y on that. This is going to take a cat pointer. Called this as well. All right. So let's keep going back through that because we found the speak twice had a second parameter there. Does anyone else? Speak does. Speak seems to have a second parameter. That's going to be this, and then we'll do an int32t again, just as our guess. Looks like it's speaking with one. Kind has a single parameter. Wag has a second parameter. Wag, wag, wag. Speak twice. We've already done. Speak also seems to. Yeah, it looks like we'll need to override all the speak functions. So let's just go look for those. We've got animal speak. I think that this is taking. Oh yeah, I could have seen that as soon as I click into the function. We see that. So this would be the first thing we'll do anyways when we get into these functions. So might as well do them now. It's a little bit more obvious doing it just from the decompilation rather than looking at the disassembly and recognizing where the calling convention detection's gone wrong. But many ways to skin a cat. They didn't react to that, so we're good. Um, and we'll speak twice. I do believe that this also seems to have a second parameter there. And 32t. We're getting some other weirdness though. Oh, because apparently I didn't set the first argument on that. This should be an animal pointer called this. So a lot of the C++ reversing so far is just a bit of repetitive behaviors here. And this is interesting. Speak twice looks to be the third function in the function pointers. Is that true? Where were we? We were in animal speak twice. Um, we're getting a little bit distracted, but we'll resume from there. Animal speak twice. Animal, the data, and then zero. Yeah, the third index would be the fourth one. So yeah, it looks like that is in fact the fourth one in that virtual table, fourth one in that virtual table, fourth one in that virtual table, and fourth one in that virtual table. So, um, where were we with it? Okay, I'm forgetting where we were. Was it in Speak Twice? Or was it in, oh, just Speak? the kind, animal speak. Oh, interesting how it's doing. Very curious. Um, oops. All right, well, we'll find that again in a minute. Um, and binary ninja function arguments are also detected automatically, and an IDA will also fail at times. No reverse engineering tool is infallible at its argument detection. This is just a particularly bad case for Ninja. I almost didn't do the stream because I was worried we'd make Ninja look bad, but it's important to know how to do this when it does fail, if it's in IDA, Ghidra, or in Ninja. Cat kind. All right. Cat speak. So speak definitely has. Oh right, all the speaks. That's what we were doing. Um, and I think that's how we found. Yeah, this right here, which is just very interesting. Very, very interesting to me. All right. We've got that one, we've got that one, we've got that one, that one. We'll do this. Um, yep, entry x1, so definitely needs that second parameter. Ah, not there, you need to click there. And then we get, right, then in 32T. There. So that looks better. We'll call it Val. And then dog speak we didn't do yet. And then dog wag has the wrong prototype all around, but it's navigating me to pet speak, not, oh, I'm looking at dog wag up there. Pet speak is fine. Let's just rename this to Val again, and we'll go to, where is dog wag? Okay, presumably this is being called in the main function there though. Did we miss it? Let's unsync. We'll go back to pet. Go back to pet is what it is. Switch back up to decompilation, dog wag. Okay, so there are multiple dog wag functions. Dog pointer, which takes this and a second argument potentially. Yeah, looks like a second one, but not a third one. And now this looks like a truly bizarre function here. Don't worry, there's a chat there. Um, didn't mean to come off too intense either. Could just be the raspiness of my voice making me sound more serious. All right. So we've got, yeah, that's weird that we're not seeing necessarily where that's being called, but, and it's doing some shenanigans in here that I don't want to think about too hard yet because we haven't actually found where it's being called. So once we find where it's being called, we can reverse that. But for now, we can live in this function as we've been. And what we were doing is going through all those functions, making sure we had detected all the parameters correctly. I think we're pretty much good. But we might discover some more along the way. Like I think jump might take another parameter. Um, just from my memory of the source. But anyways, um, let's do. Let's keep going. So we've got animal kind that prints the kind of the animal. We determined that already. Animal says %d, the value times arg2. That is very bizarre to me. We have now propagated our type information to a bunch of functions though. So let's check if our cross-references for value have updated, and they certainly have. It's being used in a handful of locations. We can see that it's being used in these types here. There are some references to it. That, and that. That seems all just to be the type references inside of other types. Types referencing types is what types are. Type references are. That little line I think about as me. So other types are referencing me, or in this case, the type I have selected, which is the value there. We also have variable references. We're referencing other variables apparently, which we are. We're using the val. Yeah, this and val are both being used in the same line as the value. We can ignore those. But now we see that value appears to only be used in calls to speak. Animal speak, cat speak, dog speak, animal. That's where it's getting assigned. And in each instance, what we're printing is that value multiplied by some other values. So I'm gonna call this like base value. Um, and it seems like that didn't automatically update everywhere, so let's just go through and update a couple of those locations. Sweet. Okay, so I think that's some sort of base value that's getting multiplied by, or in this case, added to, 64 times val plus our own value. Where's the dog's value being used? It's being used in speak, it's being used in wag, it's being used in the constructor. How's it being used in wag? Oh, okay, we get to this weird function I didn't want to reverse earlier. That is a-okay. Oh, this is a little funny little conditional pattern. Um, so if val2 is this is a signed comparison. If val2 is greater than 0, it's good. Otherwise, it's 0. Otherwise, it's 0. So then if this and 1 equals 0. I hate when the logic keeps flipping. So that and 1. So if it is greater than 0, we'll get 1. Which means if it's greater than 0, this will be false. So we'll go down to here. So if it's greater than 0, we wag. If val, if this pointer val2 is greater than 0, wag. Is what all that nastiness is saying. Then that's interesting. Um, if var20 is less than our value we're passing here, we do a different check, a slightly different check. We don't actually recheck whether that's greater. So something there weird is happening. But here's a good hint right here. Strings are always good anchor points. Dog all out of bones. This val2, if it is less than 1, we print dogs all out of bones, so this must be bones. Dogs have bones, and he can only wag his tail for however many bones he has. Very sad. There is a variable here getting you. No, not really. It's just a temporary there. We can see we're subtracting one from bones and then reassigning bones to be bones minus one. Oh, this is I. So then this must be some sort of max. I see. So we can wag a maximum number of times up to however many bones we have. Curious. Um, Sweet. And then what's this value? Oh, this is going to be our temp. All right. So I'm pretty happy with that. It seems that we're storing this register onto the stack for some reason. Why not? This is probably a very de-optimized compilation of this function, which is why we see things like that. All right, so we've got bones now, so we can update that this is bones, which means we can update that. We're going to our cross references. This function is called in this function where bones, see, we can see that bones is val2, so we don't need to go in and try to map it manually. We can just read it. Bones, we still have some value we don't know is being used, but dogs have bones. We should be happy about that. We can actually dog. Okay, so the dog can wag. How many bones does the dog have to start? So the dog has 2 bones. It speaks with a value of 1. So whatever its base value is plus its bones plus 64 times value. Weird. Um, it's just printing some weird number based off of how many bones it has. Maybe it would be obvious if we ran it, maybe it wouldn't. Um, Dog fine, just prints dog, dog speak, prints a weird value, speak twice, presumably does that twice. Dog wag, calls wag. Right click wag and then follow it and keep going. Oh, okay, we do get to it. So we can get to like, oh, does that? Oh no, that's right. This function signature is not right though. Doesn't matter? Doesn't really seem that, oh, it kind of matters. Are we actually returning the bone? We're not returning the bones from wag. Right? Disassembly. No, we're not really returning anything from wag. Go. Um, so this can also be void, which doesn't really change much, but that's fine. That's the max. All right, cool. All right, so then we can just keep going. We've got Scratch over here is interesting me. Were there any other dog functions I wanted to go through? Nope, we did speak, we did the constructor, we did the kind, we've done this wag. We haven't really looked at the deconstructors. We did this other deconstructor. We have another deconstructor, and another one as well. Another wag, and another wag. All right. Why? No, all right. So we're good with dog. Let's go to animal. Have we done everything on animal? Speak twice. Okay, we have this weird thing. We might want to get to that. The deconstructors, the constructor, speak twice again. Sweet. All right. So then that leaves cat, I believe. I don't think we've figured out yet what its value 2 is. But we did see somewhere that it can be a dead cat. So if that value 2 is less than, um, if that value 2 is less than 0, our cat is dead. Um, so actually, let's make a guess. Let's guess that this is maybe the health of the cat, and see where else it's being changed. So we can see down here, we have our cross references. We've got the one in this function. The cat can't meow if its health is below 0. Oh, and when it does meow, it does its base value plus its health. Sort of like how the dog was adding its bones. But now it's plus 32 times val instead of plus 64 times val. Ah, and now we can, of course, update the constructor to also have health as the name. But this is the constructor that gets called by the other constructor. So let's rename that to health. And this is still like the weird base value thing. And we haven't entirely figured out why it's a base value or how it's being used. Or well, we see how it's being used, but it's being used. It's not clear why we're doing what we're doing. Ah, yes, if you've just gotten here, we are just looking at some C++. We've got a classic structure of animals. We have cats, which inherit from animal. We have pets, which inherit from named and animal. So we're just looking at base pointer, how the constructors and everything like that. Annotating up a BNDB, recognizing some virtual function tables and stuff like that. I think what we just finished though is, let's go back to pets. I think we're done with this function, and I think we're done with. Oh, we're not quite done with this. Because this needs to take a that pointer called this. So we're nearly there. We're getting towards the end. And now, okay, this returns the health, but the health is a 32-bit number, so let's change this to be an N32T. And now who calls this? Oh, it's only called through the got entry. So kind of who calls the got entry right here. Um, and this returns as we. No, I haven't saved in a while either. Oh wow. So we get to do it all again. No, we're not gonna do all that again. Um, well, we kind of can, because we know a lot of what we were doing. So we know that we need an animal structure. That was a crash. It was. I'll send it in Slack later. It was on, I think I accidentally hit U on a stack variable that I had a lot of annotations on, which potentially makes sense. Um, all right, so let's go ahead and we're gonna create our new structure. This is going to be our animal. Um, we know that we can make now our cat. Now we'll do it the right way. We're gonna do it with the base structures. So we sort of had an idea of how big the cat was before. I think it was 16 bytes for the virtual, the animal, and then 8 more bytes for its own value, the health that we had. Um, but we're just gonna not worry about sizes yet. We'll do cat with a base of animal. We'll do new structure. We'll do dog with the base of animal. And we know that its offset is 0. We saw that before. And we had We also had named, which had the C++ name in there. And we had the pet. Now the pet was the weird one because, or sorry, yeah, the pet was the weird one because we're constructing named at a big offset. Let's just create the structure. Pet pointer, or sorry, pet, and now this is a pet pointer. Called this. On this, we're accessing. Okay, yeah. So at offset 10 is where named is inside of. So if we go here, I don't know if we can change the base types from here. We almost certainly can with some fancy syntax. But let's just go ahead. I'm going to save. Um, yeah, so we have our cat and dog have the base of animal. Um, and we have animal, cat, dog, named pet. Right, so we need the undefined pet. I'm gonna hit view on that. Undefined. We can see it did something there. And then we can redefine that structure with series trying to activate. We now have our pet. We know that it has animal at, oh, that feels like a bug. All right, let's undefine this again. I don't think I defined any of those structures correctly. I've been hitting enter. So we have our pet, which we know has animal at the base. You can't hit enter here apparently. You have to hit add. Enter is doing the highlighted button there. All right. So now at offset 10, we have named. Add. All right. Enter when you're in this dialogue really should hit add, guys. If any of my coworkers are watching. Um, and I do think we want to propagate data variable references as well. This is all specified in the user documentation for working with C++ tables and virtual functions, by the way, if we don't complete today. Um, all right, so we can create this, and that looks more like what I was expecting. So now we need to go, let's undefine dog, let's undefine cat, and recreate them. New structure, cat, we know it has an animal there. Create, and we'll do the same thing for dog. Dog, propagate, animal, add, create. All right. So now, if we start to set up the type of animal correctly again, this is our dog, this is our pet. Let's just go ahead and add those types. So we've got animal. Here's my type. You cat, hot dog. Oh, I accidentally cat C. Here's my type. Right now, since all these types are empty, it's warning us like, hey, you sure you don't want to use a pointer to that? That seems a little weird. And it is weird, but it's okay because we're not done yet. We're in the middle of things. So this is pet P. All right. So then we can go into the animal. The animal takes a animal pointer called this. We could also just use self if we didn't want to deal with the backticks. Oh, and this also takes a value, that base value, into T called base. Value, And then we need to propagate that forward to the other constructor. Paste that in. And then once we do that, we can see the, an animal. We have the function pointers, and then we have the special value. Just call that the base value. All right, so that looks correct to me. So now when we get to cat, what we should see is, let's fix up this function prototype. We have its value. We know it's also going to take health. And that first parameter is that this pointer, cat pointer, and this. And we need to do the same thing here. This value health. Make that field inside of cat. And now what does cat look like? So we can see that, first of all, if I want to edit this type, I said I don't know how to define the types before, but I can go here, I can go to change type, and all the fancy base pointer stuff has special syntax for it. And you can manually type it if you would like to. This padding for thing here, that's just those 4 empty bytes in the structure there. And then our 2 inherited values inside of our structure. That's really neat. So we don't need to change anything there, but it is showing us how animal is inside of or function pointers is coming from animal and base value is coming from animal. So now when we're doing things like constructing the cat, we're overriding our own function pointers as opposed to going into the animal class and then getting the function pointers out of that, which is how it would work more in actual C++. So makes sense. Looks good. Looks more correct than what we were doing before. The last little part of that is going to be figuring out the actual virtual tables. But I think I'm going to take a brief intermission and be right back. All right, welcome back. I just need to grab some more water now. Okay, so where were we? Oh, there's a lot of messages in chat here. So let's see. Let's open up the camera again here. Let's bring up chat again. So question for later. I looked at an MSVC binary, had classes like animal and cat. The animal constructor initialized X bytes, but the cat constructor overwrote X to Y bytes with cat specific stuff. Yeah, that's exactly what we're seeing here as well. The overwritten bytes in animal were unused fields of a vector made creating structures weird because the size of the constructors are super classes and subclasses did not match up. That is interesting. Have you seen a compiler reuse space like this? Oh, absolutely. We were just talking about that in our all hands earlier about data reuse in um, being done by compilers that messes up our analysis sometimes. Um, what's even worse, yeah, what's specifically annoying about the problem you're talking about is when the compiler decides to reuse the same bytes for a variable of a different size. Like if you have two for loops in a function, it totally makes sense for the compiler to reuse I both times, just a 32-bit signed integer for I. But it could choose to do a 32-bit number and then a 64-bit number using the same bytes and then a few more if it wanted to just be obnoxious. Um, so yeah, that is something that's very difficult to deal with. I'm not entirely sure how to yeah, address it in C++. I'd want to look at a minimal example if you were able to create one. It's possible you're fighting with some of the same things we were fighting with earlier, just like not recognizing certain fields and whatever it happens to be. All right. Um, so we have the cat there, we have our inherited fields. Oh, we know that this is the health here. It's cool now to see this actually populated in our sidebar as well. The thing that I'm curious about is now we need to start working with the virtual function tables. And according to, sorry for the flashbang there, um, virtual function tables, um, input compiler, of course, blah, 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 defining a virtual function table. Create a virtual function table, select the propagate data variable references, which we did. You can use the fancy attributes if you prefer typing it all out yourself. But here is an example of a virtual function table structure. This is the virtual table function for foo. And foo has a function called biz and a function called buzz, which both take foos. Now apply the new virtual function table structure to each instance of the table in the data section. You can usually find pointers to them in the constructors. So let's do exactly what it's saying here. We're going to want to create a structure to select the virtual. Select the propagate data variables references. Alternatively, um, oh, okay. I think I might have done this wrong. Now it's time to start adding the virtual function tables, starting with the base class. Add the virtual function table structures for animal and flying. Ensure to check when creating any virtual function table. Okay, I did this wrong, I believe. Because when I first created those, I used propagate data variable references not on the virtual function tables, but on the actual classes themselves. So let's go ahead and recreate our cat structure. Um, Potentially. Oh, maybe we just remove the data var refs aspect of it. Hopefully, you know what? Let's just see what the difference is. We'll have cat and we'll have cat 2. Cat 21, cat forever. We'll do the animal right at the start, and we won't click propagate data references now. What's the difference? It's that data var refs. We forgot the health, but it's really just that data var refs. It looks like. So I think it should be safe to Um, we can hit U on that type to undefine it, and then we can just go into our things here and undo that little bit of a mistake that I made. Named, I don't think had it, but pet certainly did. There we go. Okay. So now to create the virtual function tables, this is what we want to do. So let's go ahead and let's start with the animal and get to its virtual function table. And now I want to make a structure for this, it seems. Um, so we're going to do create types from CSource, and let's paste in the example we had. This is going to be vtable for animal. And now the deconstructor should, yeah, all these should return void, should return nothing. It's going to be called, it's going to have some complex names in here. Um, animal, that might need to be escaped. Um, and that takes an animal pointer are the animals are structures this time. We can convert everything to classes, but again, it barely matters. We have the second animal deconstructor. Then we have kind, which prints kind, which just prints something. Prints the kind of animal it is. And then we have, lastly, speak. Now, speak is ever so slightly more complicated. I don't think I should have these parentheses in here. Um, Okay, perfect. So one of my coworkers didn't in fact fix the fact that hitting enter when doing a base class doesn't actually enter in that base class, which is amazing. So the next build that comes out should have that, it seems. Thank you. This last one is speak. And now speak takes the animal pointer this, but it also takes that weird multiplication value. All right, so I think that this is our vtable for animal. Create. Okay, it doesn't like this, it doesn't like a couple things, so I think we need to escape a bunch with some backticks in here. And this as well, it's not gonna like. Duplicate member, animal. I know it's a duplicate member, but there are two of them up there. Um, okay. Well, what are these actually? This looks like certainly something, and this looks like. Did it automatically apply that? Oh, that's beautiful. It actually did automatically apply that. And it applied it to the wrong place. So there's more information there than the vtable for animal starts up there, which I thought it did. Oh, and it's already defined? Question mark. There's like partially a type for it. Current data variable dot. How do I get this like source version of this? Oh, type, of course. And then members? Children? There's no children, which I guess makes sense. It just says equals here. It doesn't really have a structure yet. So, where were we? Table for animal. I need to make this bigger, is what it is. It needs to have 16 bytes before any of that stuff. So let's just set structure size, add 16 bytes, and then really I need everything to shift forward. I don't want it to shift the other way. Oh, the way I'm going to do that is by double clicking on the VTable up here, and I can just move the padding from the bottom. Update. And now that looks more correct. We've got our two animal deconstructors, which are they are different functions. Oh, this one is that's what it is. It's the deconstructor for the version of the animal on the stack, and then it's the deconstructor for the version of the animal on the heap. I've never seen that before. That's interesting to me. Can I name that? All right. And then I don't know what these are either. If I make this a 8-byte number, if I make it a pointer, where does it bring me? Oh, type info for animal. So I'm guessing this is the runtime type information. I haven't worked with the RTTI stuff before, so I'm not actually familiar with what that's all doing. But we have created the virtual table at the very least. So now if I go to, well, hold on, let's not skip the instructions over here. I'm going to bring them back up. To each instance of the table in the data section, you can usually find pointers to them in constructors. I do assume, though, does each derived class need its own virtual function table? I assume that's the case. Oh, derived virtual function tables. Virtual function tables are usually used in conjunction with derived classes. To get the best results, each class should have its own virtual function table structure. So if I read the documentation, I'd answer my questions. Describe earlier mirror the class hierarchy. If foo, you would define the second virtual function table, vtable, that derives from vtable for foo. Oh, very interesting. Okay. Let's do that then. Thankfully, I don't think we need to add any virtual functions to the table for cat or for dog or for pet. No, I don't think we do. So it's just going to be effectively create new from that. So we'll do cat, dog, and pet. So we have vtable for cat. I'm gonna right. So animal, animal. I'm just gonna replace every instance of animal with cat. And then we'll do this again for dog, dog, and pet. All right. Let's go ahead and create. Oh, but I need them to inherit from. I need this nonsense here. So let's just create one of them to start. Let's do the vtable for cat. Go away, create new structure, vtable for cat. It's a vtable, so needs to propagate data variable references. I kind of just wish that said vtable, if that's all it's for. Or a better description of what that button does in the docs would also be appreciated. And then the base type is the vtable for animal at that 0 offset. So vtable for, although, yeah, you know what, let's just trust it. Vtable for dog or cat. Structure size base is vtable for animal. Let's create that. This looks crazy looking. Inherited, but all of that looks right. And then in the cat, we have those inherited function pointers. We have that base value. Interesting, 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 interesting. Does that look right compared to what's going on over here? Um, Inherited void, vtable for animal. Yeah, yeah, I think all of this is right. We just don't have any virtual member functions that don't belong to the base class, which is interesting. Um, Cool. So then you should always define these derived virtual function table structures, even if they have the same members. Allows Binary Ninja to get better results. The last step is to ensure that they are pointed to correctly in the class itself. This is often the first member structure. Make sure that each class points to its own virtual function table structure. Derived structure members can be overridden simply by changing their type. So in foo, in animal, we want this first type then to be a vtable for animal, for animal. Um, did we lose its value? We did lose the base value. Interesting. Very, very interesting. All right. Um, okay. Vtable for cat. Um, where were we? Animal here. Oh, right. So if I apply the virtual table for animal, it's actually pretty big. Oh, because it's not we're trying to reverse engineer to some C++. We're looking at some virtual function tables right now. And I just applied the type of my virtual function table incorrectly to here because I had done just the vtable for animal, but I think it's a pointer to the vtable for animal. Um, is that correct? Yes, pointer to the vtable for animal. We're going to call that vtable. And now we still have our base value, and all those bytes are being used up. I thought there were some extra bytes that weren't being used, but they are in fact being used because I made that a 32-bit number called function pointer. It's not an actual pointer to anything. Okay. Um, so we have our vtable for animal, vtable. Let's do that for cat as well. Oh, it's already doing that. Um, Except I don't think that a cat needs to be this big. Oh, but it also said that the vtable for this should be the vtable for bar, not the vtable for animal. So vtable for change that type to cat. And then it's just a little shorter, so it's looking slightly nicer. And it's also not the inherited value. We still have the inherited base value from animal, but we should also, okay, I did that on the wrong one. We should still have our health, is what I was gonna say. Vtable for cat. is there, and then we don't need this to be, we don't need all these extra bytes. I'm not sure why they're there. So let's go ahead and hit Y. Oh, I think I added them earlier. That looks familiar to me. Um, and now this is looking really good. I still think we need to apply the table for cat into the data section, and our data section does seem to be bugging out a little bit. It's been changing a fair bit. Yeah, like if I hit, yeah, anyways. Let's go back to the pets function. Pets. I'll go back to decompilation. And Um, yeah, I want to look at the cat constructor, cat calls the cat constructor calls the cat constructor, and then this is where that vtable should be. So let's apply that vtable right here. This is a vtable for cat. Vtable for, and that might be why the data section is looking weird to me. Perhaps I just need to go through and apply that to animal as well. I think maybe that slipped away. Yeah, see now if I double click it though, it is showing me what I expect. So it is misbehaving a little bit right now. Unless I'm in two different data sections and I'm not realizing it at the moment. VTable for animal. Perfect. So we have the VTable for animal, we have the type info for animal after the VTable. Um, with some interesting random pointers in here. We have the vtable for cat with some junk up front, and then the virtual member functions. Oh, and then two other things. What are these? If I make a void pointer here, is that? Nope, that's a vtable for a different object, which we are not going to worry about. Not going to worry about right now. God save my data section. All right. Let's go ahead and make the. Whoa. Okay, interesting. We can make those as fields. Why not? But to be able to get those fields to render, I still need, yeah, something funky to happen. Um, I think maybe the structure needs to be 16 bytes larger to encompass whatever this is, but again, just not sure. Um, the cat one sort of looks like it has two more things here, but the dog one doesn't. So let's go ahead and create our virtual table for dog as well. It's going to be fairly similar to this. We did the one for cat. We can do the one for dog. VTable for. I know I already did this. I just am being very careful to make sure that it's pretty much exactly the same. Um, yeah, create from seed source. VTable for dog. VTable for dog here. We can apply it to the data section. It's already applied itself, in fact, this time. We have those two weird fields, and then we have the two deconstructors, kind heap, and then something after it. I'll ignore pet for a second. Let's go back to dog. This needs to be the vtable for dog. And then dogs have bones. We haven't gotten that far yet though in this iteration. Let's save. Dog. Yeah, we haven't set any of the type information here. So we know that it's going to take a dog pointer called this, which we need to escape with backticks for it to be able to parse. We have the dog pointer called this. We have, oh, the weird value, the base value. And then I believe we have bones. Let's give those variables types. How about? All right. This is going to be dog. Where are you going? Oh, the type for that disappeared, guys. I cannot rename that. Okay, medium. Um, Strange. Very strange. Undo isn't fixing it either. It's persistent. Um, Let me just. All right, let's redo that. We got the dog pointer, all this. We have our in32T value and our in32T bones. Copy that, enter. Let's apply it here as well. Double check that I got that right. Base value is value. We can rename that if we want to. Bones is bones. Let's create that by hitting S, hit N to rename it. Bones, and now this structure here is too big. I want it to be 10. Cat does not have that same issue. Cool. Cool, cool, cool. So this is really starting to come together, guys. Um, except for the fact that my annotations in the data section keep going completely to plaid. So let's hit Y here, and I think that this should be, no, 2 up from it should be where the VTable for dog is, and it already recognizes that when I hit Y. Um, and then everything else appears as soon as I apply that. Do I need to give these names? Certainly that's not what it's getting caught up on. All right. So all that stuff comes back as soon as I tell it to, which is good. Um, Weird. All right. All right. So I think I want to do just one more for Pat if we have time. Actually, let's just click through some of these functions. I kind of want to see that speak twice function. Oh, function. Oh, I'm still on a test build. My bad. That could be why it crashed. I'm on a test build for a new feature, so it's not necessarily we're not necessarily looking at latest dev right now. Speak twice. Yeah, this right here. So this is gonna take it should be an animal pointer called this, and then we had that second weird multiplier value thing we kept seeing earlier. Um, I know in the source I called it volume. Oh, unless no, it doesn't take, no, it does. It definitely does. But it, for some reason, thinks it's calling the deconstructor for animal and not speak for animal because it is accessing the fourth element. So I did, in fact, make all these wrong and apply all these wrong, um, which is curious. All right. That's not too hard to fix, though. We can just double click into this, delete these 2 fields. Update, we can go into this, delete these 2 fields. Now you can see that it updated correctly. And it's going through the vtable, which is cool to see. As opposed to it being just an array index and a bunch of stuff like that. All right. So now, if I go to the constructor for animal, go to the constructor for animal, I go to where the vtable is, and I undefine this variable, I undefine that variable, and I redefine it here. VTable for animal, there, we're gonna undefine this one and undefine the one under it, and then we're gonna define this one here, VTable for cat. We'll undefine the vtable for dog and the one under that for dog, and we'll apply it here. Which is kind of what I was expecting, to be honest with you, but I forget why I got misled earlier down this path. So now let's go look at speak twice. Speak twice is going to take a animal pointer called this. Speak twice this. We can go to this and correct its type. We know that it's taking an animal pointer called this, and it's called speak twice, and it doesn't return anything. Why don't you like that? Why can't I make this long enough? Because my font size is up. Pointer to function cannot have const qualifier. Sure, if you insist. Um, sure, whatever. Um, animal this. And I don't know that this is all. Yeah, well, that's actually nice to see. And then that multiplied by 2, animal speak brings us to animal. How do I actually get back to animal speak now? I can't click it. It brings me to the vtable for animal. And I can't click it in animal because it doesn't bring me anywhere. So I guess I would need to go to the cross references and then find it. There we go. And here's animal speak. The problem with this might be that I haven't finished applying all the type information. Anyways, I think that's where we're gonna leave it for today. Anything? Yeah, I can save the B&DB and post it. Um, Sweet. So, thank you guys for sticking around on the stream today. I hope you enjoyed this. It was an interesting look into sort of the first approach into deducing the C++ types from sort of first principles, and then we went in and did it correctly by defining all the vtables and the base classes and all the relationships, so that instead of getting this weird raw pointer arithmetic, going through arrays of function pointers to call the different member functions, we actually just are now calling them directly, which is super nice to see that Binary Ninja can just stitch up for us. If you have any questions about this, feel free to follow up in Slack, slack.binary.ninja. And if you want this binary, you can get it in the streams channel of Slack as well. But besides that, I hope you all have a great night. Thank you for coming to our stream. And I will see you all next week.